This is Senior Algebra, Section 7.1, Rational Expressions. So today we're looking at simplifying expressions, simplifying fractions, stuff. So the warm-up here, you should have gotten 9 over negative 2, or negative 9 halves. For B, it's 0, and for C, it's undefined. If I look at B, notice it's 0 over negative 8, and C, it's undefined because I'm dividing by 0, 12 divided by 0, so it is undefined. So in example 1, it says find any values of the variable for which each rational expression is undefined, which means what? Dividing by 0. We can't do it. So if I look, what makes the bottom 0? Well, I have 3 halves, or 3x plus 2. What makes the bottom 0? Well, I set it equal to 0 and I solve. I move the 2 over, and I should get x equals negative 2/3. If I put it back in, I would get a 0 on the bottom, which I can't do. Can't divide by 0. If I look at B, at the top, well, I don't care. It doesn't matter. Nothing matters on the top here in this. It's just what makes the bottom 0 here. So I have x minus 3 equals 0, so x equals 3. Okay, so x cannot be 3 here. And then in C, I have m squared minus 5m plus 6. Well, what makes that 0? What do? How do I solve it? I factor it, just like we've been doing before in Chapter 6. So I get m minus 6 and m plus 1. So what makes the first part 0? M minus 6 equals 0, so m equals 6. And m plus 1 equals 0, so m equals negative 1. Just giving you a few seconds to copy everything down, make sure we're good here. So in example 2, I want to write these in lowest terms here. So I have 30 over 72, and I want to see what's the same in both of them. So it goes to this idea here. How can I break up 30? How can I break up 72? Well, 72, I can think of it as 9 times 8, and 9 is really 3 times 3. 8, 2 times 4, and 4 is really 2 and 2 here. Now, you don't have to break all these up, but we'll look at some ways that we can do this here. So on the bottom, I'm going to have 2 times 2 times 2 times 3 times 3. On the top, 30. Well, I can break 30 up into 5 and 6. And 6 I can break up into 3 and 2 here. So I think I have 5, 3, and 2 as my factors here. So now I have this. So question is, what's the overarching idea here of how do I cancel stuff out? How do I simplify things here? And it goes back to this. When I think of this and I look and I'm multiplying here. So if I had 2 over 2 times 3 over 5, how would I put those together? Well, that really means I multiply the tops. 2 times 3 and 2 times 5. Because I'm multiplying here, I look, and now I'm going to go backwards here. Instead of starting with that and putting it together, I'm breaking them up. And I'm going to break up 2 and 2 and make it really 1. And 1 times 3/5 is 3/5. That's why it doesn't change anything. Notice, things are all being multiplied here. So 2 over 2 is really just 1.
Maddie, right?
Yes.
Thanks.
3 over 3 is really just 1 here. And again, I can separate it because I am multiplying here. So what am I left with? A 5 on the top and a 2 times a 2 times a 3 on the bottom, or 12 on the bottom here, 5 twelfths. So that's why we can simplify things. Now, one thing that you've probably done is thought of it in terms of dividing here. So if I erase this, well, 30 I can write as 5 times 6, okay, and I can divide by 6. I do it to the same to the top and bottom, and I get 5 over 12. Or I could simply write 30 and think of it as 5 times 6, and 72 as 12 times 6. And now I have 6 over 6 because I'm multiplying, which is really just 1, and that's how I get the 5/12. So either way, one of the three ways, you're going to get 5/12 as your answer here. If I look at B, I have 14x squared over 2x cubed. The 14 and 2, well, I know 14 is really 7 times 2. X squared is really x times x. So over 2 and x. So now this is all being multiplied. I can look and I see 2 over 2. That's really just 1. And now what about the x's? I can do the same thing. I can cancel those out. So I should get 7 over x. Notice I have 2 x's on the top, 3 on the bottom. I have one more on the bottom. Think of it that way. So that leads us into part C here. So in C, I look, and I can't just simplify 12 over 20 because I have adding and subtracting between these here. So I have to factor it first and then look to simplify here. So I take a 3 out. I have x minus 4 left. I take a 5 out. I have x minus 4 left. So now it kind of becomes what we just did here. If I look up above, all these are multiplying here. Oh, 2 over 2, right? They're the same thing, right? What's 2 over 2? That's 2 divided by 2 is 1. So I use that same idea and go, well, x minus 4 over x minus 4 is really just 1 over 1. So what am I left with? 3 over 5. Notice here, I could think of this as splitting them apart really, right? Just like I kind of did up top here. Oh, x minus 4 over x minus 4 is really just 1 here. Anything divided by itself is 1. So that's where I get 3/5 times 1. On the bottom here, the bottom right-hand corner, why don't you put your favorite number? Bottom right-hand corner, put your favorite number. So looking at D now. In D, I have to factor the top. So that factors into x plus 4x minus 2. Now I have to factor the bottom. Now, in this one, I'm going to do factor by grouping. The top one I did guess and check because it's a 1x squared, but in this one, I'm going to do factor by grouping. So 2x squared minus x minus 6, I multiply the first and the last one together, I get negative 12x squared. I figure out what adds to negative 12x squared, or I'm sorry, multiplies to negative 12x squared and adds to negative 1x. Well, that's going to be negative 4x and a positive 3x. So I put those in for negative x. At this point, I'm going to look at the first two terms. What can I pull out? A 2x. I have x minus 2 left. Second two terms, I can pull out a 3. I have x minus 2 left. X minus 2 is in both of them, so I pull it out, and I have x minus 2 times 2x plus 3. So that's what goes in the bottom. 2x plus 3 and x minus 2. So now in this case, because I'm multiplying two things on top, multiplying two things on the bottom here, oh, x minus 2 and x minus 2 will cancel out. I'm left with x plus 4 over 2x plus 3. Now again, at this point, I'm done. I can't cross out the x's here because it's x plus 4, 2x plus 3. They're not the same thing on the top and bottom here. Because it's adding there, I can't just split them up and cross them out here. So it's x plus 4 over 2x plus 3. In example 3 now, we'll look at a couple different scenarios here. The first one, I have 2 minus m and m minus 2. So right now, are they the same? No, they're a little bit different, right? The 2's positive in the top, 2's negative in the bottom. M is negative in the top, m is positive in the bottom. So I can pull out a negative 1 and rewrite it as negative 1 times negative 2 plus m. The bottom, I can just pull out a 1. And now if I look, the bottom and the top are the same. M minus 2 and negative 2 plus m. Plus m, yeah, negative 2, negative 2. So these are the same. So I really have negative 1 over 1, which is really just negative 1. In B, things I look at here, well, it's subtraction here. I can't cross out the 4x and the 4x there, so I have to factor it. So if you recognize that it's a difference of 2 squares, you can see that it is 2x minus 3, 2x plus 3. If you didn't, you could do factor by grouping. 4x squared plus 0x. There are no single linear x's in there. Minus 9, and then, okay, what multiplies to negative 36x squared adds to 0x. Well, if it adds to 0x, then the numbers have to be the same, right? And that's how I think I get negative 6x and positive 6x. So I put those in. I do my factor by grouping it. The first two, I'm going to pull out a 2x. I have x minus 3 left. 2x minus 3. I pull out a 3, and I have 2x minus 3 left. So I have 2x minus 3 and 2x plus 3. Exactly what I found by guess and check as well. In B, I look and I can pull out a 2 from there. So I have 3 minus 2x. Now if I look, they look similar, but they're not exactly the same. That's a 2x and a negative 2x, a negative 3 and a 3. So I think I have to pull out another negative from the bottom. If I pulled out a negative from the bottom, first of all, I'm going to rewrite it with the x part first and then the number here, negative 2x plus 3. But I'm going to pull out that negative. So I have 2x minus 3, 2x plus 3 on the top. And when I pull out a 2, I'm going to pull out the negative as well. So I'm really pulling out a negative 2. What do I have left? Well, negative 2 times what is that? If I pull out the negative, I think I get 2x minus 3. So now, on the top and on the bottom, I have a 2x minus 3. Things are being multiplied there, so I can cancel those out. On the top, then, I'm going to have 2x plus 3. On the bottom, I'm going to have a negative 2. Now again, at this point, I am done. I can't cancel out the 2's because if it was just 2x over negative 2, that'd be fine. It's multiplying, but I have the plus 3 there. So I think I'm left with just 2x plus 3 all over negative 2. In C, well, looks like they're opposite, so I look to take out a negative 1. I get negative 1 and negative 3 minus x. Well, is that the same as 3 minus x? They're both negative x's, okay. But the 3's, that's negative, that's positive. Nope, okay. Well, all right, let's scrap that. Let's do the bottom. Let's see if I can take out a negative from the bottom. So if I try to take a negative out from the bottom, I think I would get 3 plus x and negative 1 and negative 3 plus x. Now the x's are going to be the same, okay, but the 3's, one's positive, one's negative. So I really can't get it to be the same. So at this point, there's nothing else I can do. I can't just cross out the 3's. I can't cross out the x's. So we say it's simplified as far as possible. There's no other simplification that I can do in this problem. Good luck on 7.1. Enjoy your break and have a good couple days off.